Hello, this is part 3 of the project management tutorial. We're gonna be looking at problem 3. We can see that it's different from the previous two problems. This is because up until now we assumed that activity times or durations are fixed estimates, which is an important assumption in the critical path method we've been using. However, for this problem, instead of having point estimates as usual for the activity durations, we have three estimates, A, M, and B. A represents the optimistic estimate of the activity duration. B is the pessimistic estimate. And M is the most likely estimate. Since we have variability in activity times, we will be using Program Evaluation and Review Technique, or PERT. The first thing we're gonna do is to determine the expected activity time and variance for each activity. Since the time estimates follow a beta distribution, we're gonna be using this formula to calculate the expected time and this formula to calculate the variances. And here are the results we obtained. Now we're gonna be using the expected activity times we got here to draw our activity on node network as usual and determine the critical path. I guess we've already done enough networks by now, so I'm not gonna go through the whole process again. Here's how our network turned out, and our critical path is B, D, E, G. The expected completion time of our project is 19 weeks after the start of the project. Now we move to the last question, which is about the probability that the project would be completed within 20 weeks or less. Well, we know that PERT makes the assumption that the total project completion time follows a normal distribution. Hence, to find the probability of the project being completed within 20 weeks or less, we first have to find the value of Z, which is the number of standard deviations between the due date of 20 weeks and the expected completion date of the project, which we deduced from our activity on node network, which is 19 weeks. Second, we have to find the equivalent probability from the table of normal distribution. To calculate the value of Z, we are going to be using this formula, which is the due date minus the expected date of completion divided by the standard deviation of the project. The standard deviation of the project is equal to the square root of the project variance, which is equal to the sum of the variances of the activities on the critical path, since activity times are assumed to be statistically independent. So here's the sum of the variances of the activities on the critical path, and here's its square root, which is the standard deviation of the project. So now we have everything we need to calculate the value of Z, which is 0.86. Next, we go to the table of normal distribution to find the equivalent probability. It turns out to be 0.8051. This means that there is a probability of 80.51% that the project will be completed within the due date of 20 weeks. That's all. Thank you very much for your attention.